Okay, I'm going to spend my next 10 to 15 minutes in determining the majority and minority carrier concentrations of a doped PN junction diode. We can also calculate the built-in potential if only one of the side is doped. And also, I'll show you how to calculate junction capacitance if Na and D are given. And finally, in this video, if the junction capacitance dependence is given with reverse bias voltage, I'll show you how to calculate one of the carrier concentrations if other is given. So let's start with the 10th question. So they say that a junction employs Nd is equals to 5 into 10 power 17 per centimeter cube and Na is equals to 4 into 10 power 16 per centimeter cube. Okay, now we need to calculate the majority and minority carrier concentrations on both sides. So for N side, the majority carriers will be Nd. So that will be 5 into 10 power 17 per cubic centimeter. And Na will be Ni square by Nd. So let's calculate that. 5 into, okay, Ni at 300 Kelvin will be 1.07 into 10 per 10. If you want, you can calculate. So 1.07 into 10 power 10 whole square by 5 into 10 power 17. That gives 228.98 per centimeter cube. And in P side, the majority carrier concentration will be accept atom. So NP will be Na, that equals to 4 into 10 power 16 per centimeter cube. Now N will be uh, it will be Na square by Na. So Na square is 1.077 into 10 power 10. 1.077 into 10 power 10 whole square by 4 into 10 power 16. It's 2899.8225 per centimeter cube. Now let's see the second part. So they are asking us to calculate the built-in potential at different temperatures. First we need to calculate intrinsic concentration at different temperatures. So at 300 Kelvin, it will be 1.077 into 10 power 10 per centimeter cube. We already calculated that. Now let's calculate at 250. So the equation is 5.2 into 10 power 15 into 300 power 1.5 into exponential of minus 1.12 into 1.6 into 10 power minus 19 by 2 into 1.38 into 10 power minus 23 into temperature. It's 250. It should be 250 here also. Yeah, it's 10810482.3.7. Now let's calculate at 350. Yeah, it's 2.989 into 10 power 11 per cubic centimeter. Okay, now V naught at 250 Kelvin will be, it's K by Q into T ln Na Nd by Ni square at 250. Put 250 here, Boltzmann constant, charge, you will get 0.905 volts. And V naught at 300 Kelvin will be, yeah, it will be around 0.849 volts. and V naught at 350 Kelvin will be 0.7789 volt. Okay, yeah. Now let's go to the next question. So they say due to manufacturing error, the P side of a PN junction has not been doped. If ND is equals to 3 into 10 power 16 per centimeter cube, we need to calculate the built-in potential at T equals to 300. Built-in potential V naught will be VT ln Na ND by Na square. So VT will be 26 into 10 power minus 3 ln ND will be 3 into 16, 3 into 10 power 16. If Na is not there, then it will be intrinsic. So in intrinsic, N equals to P equals to Ns square. Okay. Sorry, N equals to P equals to Ni. So it will be Ni by Ni square. It will be cancelled. So the value will be 26 into 10 power minus 3 into ln 3 into 10 power 16 by Ni. It will be 1.077 into 10 power 10. So it is 0.385 volts. Okay, now let's go to the next question. They say that a PN junction with ND and Na is given experiences a reverse bias voltage by 1.6 volt. We need to find out junction capacitance per unit area. So junction capacitance per unit area will be Cj equals to Cj naught by 1 minus Vr by V naught, where Cj naught will be epsilon Q by 2 Na Nd by Na plus Nd into 1 by V naught root over. Okay, let's first calculate V naught. V naught will be 26 into 10 power minus 3 ln Na is 2 into 10 power 15 and D is 3 into 10 power 16 by Ni square. Okay, 26 into 10 power minus 3 into ln 26 into 10 power minus 3, sorry, 2 into 10 power 15 into 3 into 10 power 16 by 1.077 into 1.077 into 10 power 10 whole square. Yeah, it's 0.701 volt. Now plugging these values in this, we get Cj naught as epsilon value is 11.7 into 8.858 into 10 power minus 14, taken centimeters because we have a Na concentration centimeters, into 1.6 into 10 power minus 19 by 2 into 2 into 10 power 15 into 3 into 10 power 16 by 3.2 into 10 power 16. Okay, into 1 by 0.701. Did a mistake somewhere. Okay, this is a 14.89 nano farad per centimeter square. If you plug these values here, you get Cj is equals to 14.89 by root over 1. It is reverse bias, so take it plus 1.6 by 0.701. Plugging these values, you get 1.489 by root over 1 plus 1.6 by 0.701. You get 0.82 farad per centimeter square. Okay, now let's go to the next problem. The next problem says, an oscillator application requires a variable capacitance with the characteristic shown in figure 2.39. So we need to determine the required ND if Na is given as 10 power 17 per centimeter cube. Okay, so the characteristics are, for reverse bias voltage of 1.5, it's 1.3, and for 0.5 it's 2.2 Cj. Okay, we can write Cj is equals to Cj naught by root over 1 plus 0.5 by V naught equals to 2.2. This is Cj1, and the Cj2 will be Cj naught by root over 1 plus 1.5 by V naught equals to 1.3. Let's take a ratio and find out V naught. If you do that, we get V naught equals to 0.03763 volts. Now plugging this value here, we get Cj naught is equals to 2.2 into root over 1 plus 0.5, 0.03763. It is 8.315. It will be femtofarad per micrometer square if you check in question properly. Now Cj naught is root over epsilon q by 2 Na Nd by Na plus Nd into 1 by V naught, 8.31 femtofarad per micrometer square. Now finding Na Nd by Na plus Nd, that is 8.31 into 10 power minus 15 whole square. Because it is femto, there is a micro here, it will be 10 power minus 12. Okay, into 2 into V naught is 0.03763 divided by epsilon q. Epsilon is 11.7 into 8.858 into 10 power minus 12. You take in meters because it's taken as meters here. Okay, into charge 1.6 into 10 power minus 19. We get 3.13 into 10 power 11. Given Na as 10 power 17, if you substitute, you get Nd is also similar to 3.13 into 10 power 11 per centimeter cube. Yeah. Okay, that's it for today. We'll meet in next video. Bye.